append to arithmetic sequence and series. So first let's talk what a sequence is. A sequence is any list of numbers. So 1, 2, 3, 4, dot dot dot, 2, 4, 6, 8, dot dot dot, 5, 25, 125, 1, 1, 2, 3, yada yada. Any list of numbers is a sequence. Now, some sequences have a pattern, some do not. If you look at the sequence here, all we're doing is adding 1 every single time. If you look at the sequence here, 2, 4, 6, 8, we're adding 2 every single time. Over here, 5, 25, 125, you're multiplying by 5 every single time. And then over here, I said 1, 1, 2, 3. If I kept on going, there is actually a pattern here, which would be 3 plus, if you add the first two terms, 1 plus 1 is 2, 1 plus 2 is 3, 3 plus 2 is 5, 5 plus 3 would be 8. That's also a sequence. 5 plus 8 would be 13. So there are all types of sequences. What we're going to focus on today's lesson is a sequence where you're adding each term. That's what an arithmetic sequence is. One where you add to get the next term. So like 1, 2, 3, 4 is the arithmetic sequence. 2, 4, 6, 8 is the arithmetic sequence. By the way, you can also subtract. So let's say I start at 10 and then subtracted 3. That's also an arithmetic sequence. So if you just add or subtract, it's an arithmetic sequence. When you multiply by a common ratio, that's called a geometric sequence. That's me on the next video. And a series, before I move on, what a series is just like a sequence, but you're adding up all the terms. So it's 1 plus 2 plus 3 plus 4. Or 2 plus 4 plus 6 plus 8. So sequence series are just a list of numbers. A series, when we add those listed numbers, the sequence is when we just list the listed numbers. So let's talk about arithmetic sequences in more detail. So when we know something is an arithmetic sequence, we can actually find any term we want using this formula here. It's called the nth term of arithmetic sequence. It lets you find any term you want of an arithmetic sequence. So let's talk about what each thing does. So an is the nth term. a1 is the first term. There's an S. N's a term number. And then D is what we call the common difference. That's what you add or subtract every single time. So for example, let's go 2, 4, 6, 8, that form we saw up there. If I was plugging this into this equation here, 2 is the first term, 4 is the second term, 6 is the third term, and 8 is the fourth term. And let's say I wanted to find the 11th term. Right, so how would I plug this formula in? Well, the first term I'll plug in, it would be 2. So I'll go to here. Now the mth term, what term am I looking for? I'm looking for term 11. So I'll put 11 here. And then I figure out the common differences. Well, it goes 2, 4, 6, 8. I'm adding 2 every single time. That goes here. And I'm looking for the 11th term, so this is A11. And then when you simplify it out, you get your answer. 11 minus 1 is 10. 10 times 2 is 20. 20 plus 2 is 22. So it lets me know that the 11th term is 22. That's all that means. The 11th term of the sequence would be the number 22. Okay, so now that hopefully you have a better understanding of that, let's do some of these problems. Find the indicated term number of each arithmetic sequence. So they give me the first term, they give me a common difference, they just want me to find the 9th term. That's what that means. Let's find the 9th term. So use the formula. And we're just going to sub things in. So the first term here is -4. Common difference is 6, and they want me to find the 9th term, so I'm going to plug that in for 9, and here too. So A9, my A's look like 9s, sorry. A9, not much better. So this would be -4 plus 9 minus 1, which would be 8 times 6. And then multiply that, 48 minus 4, so 44. So the 9th term of the sequence, A9, that's going to kill me, is 44. Damn, I'm so bad at writing A's. So that's the problem. 1b. So find A20 given this information. So kind of the same idea. Write down the formula. AN equals A1 plus N minus 1 times D. And sub everything that's proper in. So my first term is 15. My common difference is -8. Now, they don't tell me what N is, but they kind of do. Right here, right? A20. So I want the 20th term. So this is 20. And plug 20 in. So A20 would be 15 plus 19 times -8. And whatever that turns out to be would be my answer. Let's go to the ones I think are a little more fun. So find the indicated term of the sequence. This is the same thing. We're going to skip that one. Let's do this one. This one's the one I'm talking about. So want me to find A18, but they just give me a sequence. They don't tell me anything else. So we're going to do the exact same way. Let's list out the formula. AN equals A1 plus n minus 1 times D, the common difference. And let's find all that stuff. So A1, first term, 12. Common difference, well, we actually got to do it ourselves. So if you want to find a common difference, all you have to do is do A2 minus A1, or just subtract the second term from the first term. So I get 13. It also works here. If you do 38 minus 25, 13, 25 minus 22, 13. You just get one term minus the one before it. So that's 13. And again, they don't tell me what n is, but I know I want A18. So the 18th term I'm looking for, and that's plug in 18 for n. So A18 would be equal to 12 plus 17 times 13. And then whatever that turns out to be is our answer. Okay, so now let's do similar but little slight difference. In this case, they just want me to write the equation. So just a generic equation I can plug stuff into. So let's do an easy one first, this one right here. So we're going to start the same way we always start. We're going to write down the formula. So n minus 1 times D. Then we're going to plug in what we can plug in. So my A1 is 12. My common difference, remember if you're not sure, you just subtract. I'll get this term minus that term. 3 minus 12, negative 9. And that's all I have. Simplify a little bit. Distribute that negative 9. AN equals 12 plus negative 9n plus 9. Add the common terms. And I get negative 9n plus 21. And that's my general formula. So now if I want to find the 12th term, I just plug in 12 and get my answer. So general formula, you just leave it with the n in it. Now this one's a little bit tougher. So they want the general formula. So let's write it down like we always do. A1 equals equals A1 plus n minus 1 times D. And you should notice a problem. I don't have A1. So what happens here? Anytime you have something missing, sometimes you're missing A1, sometimes you're missing D, sometimes you're missing N. Well, in this case, you're always miss N. What you do is you go back to the original formula. So I'm going to go over here and write the original formula down again. And let's plug stuff we do know in. So now D is 8. And right here they tell me A6 is 12. So what does that mean? That means when N is 6, my term here is 12. So let me take an extra step. Like this. Remember what it's saying is when I plug 6 in for n, this answer here is going to be 12. So 12 equals A1 plus 5 times 8. And if you look at that, I can figure out what A1 is. So 12 equals A1 plus 40 minus 40. A1 equals negative 28. Now I could go back, plug that in here. My common difference is 8, and I am done. Here's my formula. I should simplify, but I'm trying to save a little time, so I'm not going to. But that's the general idea. So anytime you get the right in formula, you're missing something, just go back to the original formula and plug in what you do have. In this case, we did have the 6th term was 12. So when I plug in 6, it equals 12. I was able to solve for A1, and I was able to move on. Let's do another one of these. This one's too easy, right? There's my A1. My common difference is 6. It's plugged into the formula. Let's do this one again, just so we have another practice of it. So I'm going to do AN equals A1 plus n minus 1 times D. Right, I need to find A1. I don't have A1. So what I'm going to do is rewrite the formula. I keep on doing that. N minus 1 times D. Plug in what we do have. I have D is negative 4. And I have the 5th term is negative 12. So when I plug in 5, it equals negative 12. So the 5th term is negative 12. So I get negative 12 equals A1 plus 4 times negative 4. Negative 12 equals A1 plus negative 16. Add 16 to both sides. A1 equals 4. So now I have everything I need. Plug in my A1, plug in my common difference, and there I go. This one I will simplify all the way just because it's a little easier. Negative 4 plus 4a. Then we add up like terms. So 8 minus 4n. Or if you prefer, negative 4n plus 8. It's like the slope of a line. It's actually exactly like the slope of a line equation. Right, where here's the slope, here's the y-intercept, it's just a line equation, linear line equation. Anyway, let's move on. So we're done with that concept. And we're going to talk about how to find the arithmetic mean. This arithmetic means it means the average, right? Mean is average of when adding. Well, that's like the normal average. If I want you to find the average of two things, just add them up and divide by 2. So we're going to talk about find the arithmetic mean between a sequence of numbers. So how do I find that all these question marks here? Well, what we're going to do is start with the middle one. If you want to find that number, well, it's the middle of these two. It's the arithmetic mean of these two numbers. So we're going to add those two numbers up and divide by 2. So I get 48 divided by 2, which is 24. So that number is 24. Now if you want to find this one right there, well, that's in the arithmetic mean of these two numbers. So do the same thing. Add them up and divide by 2. Did I say 4 earlier? So I get 24, and I get, divided by 2. It gets me 30 divided by 2, which is 15. So that's the number that goes there. That's the arithmetic mean of these two. Now do the same thing here. If you want to find the arithmetic mean of 24 and 42, just add the two numbers, round it up, and divide by 2. So I'm going to get 66 divided by 2 is 33. And there you go. So we'll do the same thing here, but we should just move on. Let's talk about arithmetic series. As I mentioned earlier, a series is just a sequence where you add the numbers up. So if I give you a sequence 1, 2, 3, 4, the series of it's just adding them up. That's the only difference. So now when I have a series, I can find the actual sum of it, or the partial sum of it, because I'm not going to add the whole thing up. We're just going to add up certain, like the first 10 terms, or the first 11 terms. And we have two formulas. We have this formula right here where you add the first term plus the last term and divide it by 2. Basically find the arithmetic mean, and times by the number of items you have. Or you can use this one, which I actually prefer sometimes. I know it looks longer, but for me, I like it because I don't need to find the last term, which is just this formula here. So let's do a couple examples. So when we find the sum of each arithmetic series. So let's do this one here. So let's do the first equation. So that'd be sum s of the n of the sequence here. Just find the formula. It's n a1 plus an all over 2. Alright, so that's the formula right there. So a couple things with this formula. It's like always, we just gotta plug stuff in. So what's the first term? Easy, 2. What's an? That's the last term of the sequence right here. So an in this case is 100. Now we do have one problem though. What is n? Right? Nothing tells me here. So you could do a couple ways. You could look at it, 2, 4, 6, 8. How many items do I have? It's going to be 50. I'm adding to 1 through 100, but counting by 2s. Or if you're never sure, what did I say earlier? Go back to the original formula. an equals a1 plus n minus 1 times d, right? Anytime you're missing something, in this case I'm missing n, you go back to the original formula, plug in what you do know. Well, I know the first term is 2. I don't know what n is, but I know the 100 an is 100. And I know my common difference. We're adding 2 every single time. Right? Now the only thing I'm missing is my n, so I can solve it. So remember, anytime you're missing something, you just go back to the original equation. Subtract 2. 98 equals n minus 1 times 2. I'm going to divide by 2 here. You can distribute if you want. Then we're going to add 1 to both sides. So 50 equals n. So now I have my n. And that's pretty much it. Now we just got to simplify it. So s of 50, I guess, we're adding the first 50 terms, will be 50 times 102 divided by 2, which is the same thing as 50 times 51, which is the same thing as saying 2, 5, 25. So that's the idea there. So again, keep in mind, use the formula. Anytime you're missing something, go back to the original equation and find it. Let's do the next one here. N, A, N, and D. So right, so use the formula, use the normal one. right? Plug in what we know. I know AN is 240. I know the common difference is D, which doesn't help me here. I know N is 16. That's nice. But again, I'm missing something. I'm missing A1. So anytime we're missing something, you go back to the original equation and plug in what we do know. Right, so what do I know? I know the common difference is 8. I know the nth term is 240. So now again, N is 16. So let me do that first. N is 16. And AN is 240. It's right here. And look at that. Only thing we're missing is A1, which is also what I need up here. So simplify. So A1 plus 15 times 8. That's going to be 120. Plus A1 equals 240. Subtract 120 from both sides. So I get 120 equals A1. Plug it in. And then you just simplify. It would be 16 times, what would that be, 360 divided by 2? And whatever that turns out to be would be my answer. Right, so again, use the formula, plug it in. If you're missing anything, go back to the original. Let's do some of the first 50 natural numbers. But in this case, since we used that one twice, I'm going to use the other equation. Let me use this one. I'll show you why I like that one sometimes. So that equation is this. Sn equals 2 times A1, I believe. It's been a while. N over 2, 2 times A1. That's what I was missing. N over 2, 2 times A1 plus N minus 1 times D. So that's the formula. Now we're doing the first 50 natural numbers. So if you think of natural numbers, right, from chapter 1, 1, 2, 3, 4, blah, 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 dot, dot, dot. So the first natural number is 1. I'm doing 50 natural numbers. That's my N. That goes here also. And then D is the common difference. Well, look at natural numbers. What's the common difference? Every single time I'm adding 1. So there you go. Now we just got to simplify it. So 50 over 2 is 25. 2 plus 49 times 1. The only hard part here is don't forget parentheses are a big deal. So you do this first, 49, times it by 1. So you get 49. You add it to 2. And once you get that, then you can multiply by 25. So just gotta follow your order of operations. So I'm going to get 51. And then whatever that turned out to be would be my answer. Same thing if I use this one. Right, I have my first term. My common difference is 4. What's missing here? I'm missing N again. So it'll just be like one of these. So I'm going to skip that one because we've done that a couple of times now. But in this case, you're just missing N. You have your AN, you have your first term. You don't have the N though. So let's start with this one. We're going to go backwards using this formula. So you can use some formula to find terms of the series. So we're going to have summations, and we're going to go back and try to find the first 2 or 3 terms. So that's what it says right here. Find the first 3 terms of this arithmetic series. So if you notice, they give us the sum. Right, since they give us the sum, we're going to use the sum formula. So that we're going to use Sn equals N over A1 plus AN all over 2. And I'm honest with you, I'm not a fan of that formula. I actually use it more like this. That's how I think most books have it. That's better. So Sn equals N over 2 A1 plus AN. Then we plug in what we know. I know the sum is 120. So this guy is 120. I know N is 8. And I know AN is 36. Look what we're missing. The first term. So all we gotta do is solve this problem here. 8 over 2 A1 plus AN. 8 over 2 reduces, and I just get 4. A1, so that's not AN, I know it's 36. Plus 36. Little hint, instead of distributing, just divide by 4. So I get 30 equals A1 plus 36. Then we're going to subtract 36 from both sides. A1 equals negative 6. So that's the first term. They want me to find the first 3 terms. So I need the common difference, right? I need D. But I don't have it anywhere. So remember what I always say. If you're missing the common difference, we're not going to do that one. Go back and put the original formula. Anytime you're missing anything, so what I meant to say, go back to the original formula. So look what happens here. I have A1 is 6, negative 6. I have N is 8. And I actually have an is 36. So I could find the common difference. So let's simplify this. 8 minus 1 is 7, 7d. So add 6 to both sides. I get 42 equals 7d. Let's divide by 7. I get d equals 6. So my common difference is 6. Well, how does that help me with the first three terms? Well, very simple. I know the first term, a1 is negative 6. I need to find the second term and the third term. Well, if the first term is 6, if the first term is negative 6, my common difference is 6, all you have to do is add 6 to get the next term. That's how it works. It's an arithmetic sequence. So I get 0, add 6 again, and I get 6. Those are my first three terms, right? Once you know what the first term is and you know what the common difference is, you just go on adding the common difference to get your next three terms. Let's do one more of these so you can see it one more time. So again, first three terms. Now in this case I have a1, I have an, and I have sn. So let's write down the formula. That is n over 2 a1 plus an. This time it looks like I'm missing my n. So do it the same way. Plug in what we know. a1 is 8, an is 100, so I get 1296 equals n over 2 times 108. So then I'll reduce this first. So that cancels out. I get 1296 equals n times, this reduces to 54. N times 54, then we'll divide by 54. And n would equal 24. Thank you, off-camera calculator. So n is 24. Now, what do I need? I just need the first three terms. I actually have the first term already. We're not going to do that one. I have the first term is 8. The second term I'm looking for. The third term I'm looking for. Well, why did I do that? Because n helps me figure out what the common difference is, which I do not have. So how do I find the common difference? Well, it's missing. So we write down the original formula. Every time something's missing, we go back to that formula. And then we write down what we do know. a1 is 8. an is 100. That's this guy. n is 24. And now we can find the common difference. So 100 equals 8 plus 23d. Subtract 8. So 92 equals 23d. Let's divide by 23. And I get d equals 4. So that's my common difference. Again, how does it help me? Well, if I know the common difference is 4, and I know the first term is 8, all I gotta do is add the common difference every single time. So I get 8 plus 4 is 12. Add it again, and I get 16. And there's the first three terms. Okay, almost done. Let's talk about sigma notation. So sigma notation is when you see a big O sigma, this Greek letter called sigma, and all it means is sum or add, right? That's all it means. Capital sigma just means sum. So we look down here. This is a typical problem. K equals 1, then they give you an equation for k plus 2, and then they give you a top number pair. So what that is it's, as explained so perfectly right here, is that bottom number is your first value. This is a formula. I just want to plug it in. So plug in 1, plug in 2, plug in 3, up until you get to the last value here. So the last value is like a big old stop sign. Remember how to draw a stop sign. Big old octagon, stop. So you just keep on plugging 1, 2, 3, and 2 is the stop sign, and then you add them all up. Because that's what the sigma means. This means sum them all up. So if I was going to do this problem here, I would start at 1, plug it in. 3 times 1 plus 9. Then you go, okay, 3, keep on going, 3 plus 2 plus 9. 3 times 3 plus 9, all the way till you get to 3 times 12 plus 9. And then once you get your answers, 12, 15, looks like we're adding 3 every single time, so 18, blah, 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 blah. 36 plus 9 is 45. I would add all these up. That's how sigma notation works. You plug the bottom number into the equation, up until, keep on doing that until you get to the top number, then add them all up. That looks like it takes forever. It does. So the shortcut. This means sum. We have a sum equation for arithmetic sequence. It's this guy. N over 2 times a1 plus an. Now if you look over here, I have my first term. I plugged in 1. I got 12. I have my last term, 45. Now n's a little tricky. N is 12, and that makes sense. 1 to 12 is 12. But if you subtract it, you actually only get 11. But when you're counting, it's how many things are between 1 and 12. 1, 2, 3, all the way to 12 is actually 12 terms. So it's 12. So I'll get 6 times 12 plus 45, and whatever that equals will be my answer. Now, what am I doing this one here? Same idea, right? I would need to figure out the equation, n over 2 times a1 plus an. Now if you notice though, this starts at 4. So like, how does that work? Well, that's just my first term. A1 is just plug in 4. So 4 times 4 plus 1, 16 plus 1 is 17. Would my an be? Plug in the top number, 13. So 4 times 13 plus 1, that is 52 plus 1, which is 53. Now, how about my n here? So first, if you notice, we start at 4, right? So it's not 13, because we don't go through 13 numbers here. We go from 4 to 13. That's actually 10. I know if you subtract, it's 9, but it's always one more than that, because we count from 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There's actually 10 items we have there. So my n here would be 10. So you simplify it, 5 times 17 plus 53. And actually get, I could do that, 60, 70. So 3,500. Now I got good news for you though. This problem could also be done on a calculator. If you go to math and your calculator is updated, and go all the way down, I'm gonna go up because it's a little faster, to summation. You get a thing that looks like this. And all you gotta do is plug it in. Now you can use any variable you want. You don't have to plug k. You can do anything you want. I'm gonna use x, this is easier. Let's do the bottom one here. So we start from 4, we're going all the way to 13. And plug in 4x plus 1. Hit enter, and you get 350. Same answer. So now you know 3 ways of doing this. One way is the old school way, where you just plug in 4, plug in 5, plug in 6, all the way to 13, and then add them all up. That's all this means. Another shortcut is use the summation formula. Since it's a summation, all you gotta do is find the first term and last term and the number of terms, plug it in. And then finally, I'm guessing these are gonna be your favorite, just plug into the calculator. And that's it.